of electronic.
Should we move to next presenter? I think Dr. Naveen is not around.
Around, not around. So our next presenter is Eastern University of Engineering and Management Science. Will present college case study on the emerging display technology using zeolite catalyst.
Hello, madam, I am audible?
Yes.
Okay.
Hello. Yes. Kindly share my slide, please, from their side.
Okay. Do you want to please assist with the slides?
Share your slide. Can we share your slide?
Yes, please.
Yes, Dr. Sophia, we are sharing from our side. Just a minute.
Thank you. The topic of my presentation is Thermotropic Cholesteric Phase Study of the Emerging Display Technology. I am Dr. Mustafa Alai, Associate Professor from the BCom and the National Academic Scientist. This year, just Government of Pakistan recognized me as a scientist. Nearly 110 publications have been published, and I am also the Vice President of Chemical Society from the Balochistan chapter. The main thing, please share my slide from your side.
Just a minute, Dr. Mustafa.
Yes, sir. Just I'm asking about my work because time is very limited. And 20, 15 minutes is too much limit. But again, I try to my best to complete my presentation. I have preparing the smart glass technology with the help of the liquid crystal, epoxy monomers, and hardener. In this research, we have used first time in the zeolite catalyst. Zeolite catalyst sometimes act as an hardener and sometimes act as a catalyst. And both type of this we have used in our this research. And what is crystal? I'm waiting.
I couldn't see any slides they shared, dear.
Yes, yes. Now share it.
Yeah.
And now
Yes, thank
clear. Now clear,
you.
yeah.
Yeah, yeah, yeah.
Okay. All right.
Thank
Please
you.
use the slideshow.
Yes, yes. The topic of my presentation is the thermotropic cholesterol phase of the emerging display using zeolite. Okay, this is the my content. Next, please. Next. What is liquid crystal are the very important in the study of the optic chemistry and the polymer science. Next, please, next. And the discovery of the liquid crystal over the century and since the phenomenon is applied to the many products of our society. Okay, this is the systematic diagram of the 3D, 1D, and no lattice and no orientation of the isotropic of the liquid crystal phases. There are three main types of the liquid crystal: nematic, sematic, and cholesterol. This is the phases of the liquid crystal. And furthermore, it is divided into three types: thermotropic, nitrotropic, and metallotropic. In this research, we have used the thermotropic of the liquid crystal. Please next. In this, here you see the two main types of the anisotropic which is present in the molecule of the liquid crystal. The dielectrical anisotropy and the positive or negative, having the property of the transmitting electric field without the conducting insulating. This next. Thank you. This is the systematic diagram of the liquid crystal before heating 145, and after that 178, it is clearly transparent. Next. This is the phases of the symmetric and cholesteric and the symmetric of the phase of the liquid crystal. Next. This is the, yes. This, okay, thank you. This is the dielectrical anisotropy having the property of the transmitting electric force. What happens, what is the, what can you say, the phenomenon present when we apply the light, the liquid crystal will align the parallel to the electric field upon the application of the electric field. The positive charge is displaced to one end of the molecule and the negative charge to the other end of the molecule, thus the creating an induced dipole moment. This results in the alignment of the longitudinal axis of the liquid crystal molecule mutually parallel to the electric field, and short range positional order and the long range of the orientation order. Here you see the positive side move to one end and the negative is the center of the field. The field is total opaque. Next, please. This is the how we formation the PDSC film. Here the following method we use: peak steep shift method. With the help of this method, we have used for the PDSC smart glass, because the main composition of the smart glass is liquid crystal, epoxy monomers, hardener, and if we drop the nanoparticles over that. Next, please. This is the addition polymerization reaction is take place. Here you see the primary, secondary, and tertiary alcohol are formed. Next, please. This is our experimental work. And again, next, please, next. And this is the thermotropic cholesterol phase of the emerging display technology using zeolite catalyst. This is the apparatus used in our research and how to prepare our film. Next, please. In first step here you see, next, the checking the ITO coated glass. We have used ITO coated glass, then clear after the removing the undesirable particle, we prepared our panel, or you can say 2 by 3 panel. Then with the help of alligator clip, we incorporate it. After that, we incorporate the different types of the epoxy monomer, the composition of the liquid crystal and other thing, and then back with the help of the our oven and prepare to smart glass. Next, please. This is the chemical structure of our compound. First one here you see the neopentyl glycol diglycidyl ether. It is pentafunctional. Second one is ethyl glycol diglycidyl ether. It is difunctional. These is two monomers I have been used in my research, and the liquid crystal is the nematic liquid crystal and the hardener is triethylene tetraamine. Here we have used the worst reaction ROR, which is addition polymerization reaction. Second one, the catalyst is the zeolite sodium aluminum silicate, which is work as a catalyst as well as hardener. Next, please. Because theta also we have used, but also it is used as a catalyst. This is the composition of our sample. 7 hours we have prepared, and the temperature is 343 Kelvin. There's the different composition we have prepared. In first MM1 sample, here you see the ethylene glycol and neopentyl glycol tetraethylene ether 2:1 ratio. And second one MM2 we have used ethylene glycol diglycidyl ether, neopentyl glycol diglycidyl ether, and second one we have used zeolite 2 with 3%. Next, please. The morphology we have been used. Please next. With the help of the scanning electron microscopy, here you see the morphology is continuously decreasing due to the increasing of the new pentyl glycol diglycidyl ether, which is pentafunctional and which is the more efficient to participate to prepare the film. And second one to isolate. Here you see how the film is clearly what can you say, the size of the liquid is a dominant and the droplet decreases. And second one is the systematic diagram of the polymerization tube gas separation method, thermal velocity density. Next, please. This is the electro-optical properties. Please, next. Next. Thank you. But okay, okay. Please, previous one. This is the previous one. This is the electro-optical properties of the thin film. What is the electro-optical properties? Electro-optical properties of PDSC film can be affected by the liquid crystal concentration, separation degree, dimension, composition ratio, monomer morphology, and other factors also involved to prepare the film, which is the curing effect of the speed of polymerization, diffusion, and the solubility. Here you see the sample and previous one, the electro-optical property. Please, previous one. If you show previous one, please. Hello. Previous slide. Previous. Previous. Back side. Back. Yes. Thank you. This is the electro-optical properties. This is the backbone of our film. Here you see the transmitter. Next. It is the morphology. Next one. After that, next. This one. But okay, chalo, no problem. This is the here you see the transmitters are our fin is very clear. This is the another systematic diagram of our fin. The main electro-optical property depend upon the following parameters, which is the threshold voltage, saturation voltage, rise time, decay time, and such type of contrast ratio. And here you see we have prepared our fin is very clearly just with the on step our university Bhutan, Biological University of Information Technology and Engineering. How is clear? Just one click when it is totally turned from the opaque to the transparent medium. And what is the application next, please? The main application of our film is the switchable privacy window, light shutter, electronic paper, projection display, direct view display, healthcare center, effective patient isolation, hospital, smart helmet, smart minimize the social distancing, security command and control established through the eco-friendly. And the conclusion of my presentation is that the polymer, next please. The conclusion of my presentation is the polymer disperse crystal film was prepared by the polymerization induced phase separation method with the nematic liquid crystal content lower than the 20% of the electro-optical properties but carefully investigated. The composition ratio, weight, and the combined effect of the curable epoxy monomers have significantly influenced the morphology and the electro-optical properties of thermal cured PDSC film. On the morphology, pentafunction monomer with two bulky methyl group, here you see in the new pentyl glycol diglyceride ether, increases the cross-linking density as well as the polymer network of the PDSC film, which is regularly with the increasing of the catalysts which have used with the trisilane tetramine as well as zeolite work as catalyst as well as using the hardener, resulting the reducing the morphology of the thin flexible PET coated of the thin PDSC film. The electro-optical properties of morphology of the PDSC film will strongly influence the chemical structure of curable monomer of difunctional ethylene glycol diglyceride ether and the pentafunction of neopentyl glycol. Next, please. Resulting in the reduce the liquid crystal domain size of the film, which decrease the decay time, increase the contrast ratio, rise time, threshold voltage, saturation voltage. This study also showed the special association between the composition of heat content curable epoxy monomer structure and the electro-optical properties of PTSD film with decreasing morphology. Moreover, the results have been presented in this study also suggested that it is possible to regulate the liquid crystal domain size and optimize the electro-optic performance by adjusting the composition ratio and feed ratio, weight ratio, or percentage, what we can say, and structure, or what can we prepare, how to prepare one. It is depend upon our composition and the structure of di and pentafunctional curable epoxy monomers to obtain the PTSD film with positive good electro-optical properties. The result in this paper being significant advantage for manufacturing of polymer disperse liquid crystal film and developing film marketing. Next, please. This is the technical specification of my film, optical properties, electro-optical properties, and specification. You can see how is the good and the lifetime of my film nearly 1,000 hours, and it is much more good and it is totally applied. Next, please. And I acknowledge I am very grateful to the High Education Commission of Pakistan who gave me the opportunity and the funding and NRP project and the audit of the Palestine University, Bhutan, and the author thankful also the different advanced polymer laboratories of the Bhutan. And this is my Adnan Murad Bhayo, another doctor which are doing PhD in Canada, Dr. Furqan from Chemical Engineering Department, my student Fazal Qadir. This is my references. Next, please. Next, please. This is my references. And this is my web link. Next, please. 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 But I am ending my presentation. I try to my best to complete my presentation within 15 minutes. This is my web link. And next, please. Next. This is my the picture portfolio of my PhD student working in my lab. This is my group. And this is next. This is my research group. Thank you very much. Any sort of question you mind, please ask me. This is the pattern work. Recently, my book has been published in the Cambridge University with the help of, and nearly I have granted nearly 3 patents and filed 8 patents. And also I have published 2 books in this context. Thank you very much. Thank you very much for the Society of the Emerging Scientists who give me opportunity to present my work. Thank you.